Good morning or good afternoon, depending on where you're joining us from, everyone. My name is Blona Dodi. I'm features editor at PV Magazine, and I'm delighted to welcome you along to this session exploring the increasingly important role of technology in solar plant operations and maintenance. Now, as we know, the PV industry is renowned for its competitiveness, driven by its focus on lowering energy costs and delivering clean energy, while at the same time maximizing project revenues and cutting CapEx and OpEx. So it makes sense that solar professionals are turning en masse to tools like artificial intelligence, automation, and other software services to streamline their operations. And as the industry keeps growing and more projects are added to the grid, we are seeing in real time the value that having technical tools function as a sort of intelligence layer for operations and maintenance can provide. So how can tools like digital twins, automated drone inspections using thermal thermography or electroluminescence testing, data analytics platforms, cybersecurity tools, machine learning algorithms, SCADA systems, web-based remote monitoring, how can these all help asset owners and O&M professionals to maximize their project's efficiency and value? Sorry, we're just technical difficulty here. Stay tuned and we'll delve into all of these topics and more. I'm delighted to say that we have a full rota of guests joining us today from some of Europe's biggest EPCs and IPPs to O&M software specialists and startups, and they're all leading the charge when it comes to developing emerging tools and creating standards which the entire industry can learn from. But first and foremost, however, a big part of figuring out technology's growing role in any industry is research and development. And so it's very important for us to contextualize all of this innovation and these questions that we're about to hear about and answer in a big picture format. And to help us do that, I'm delighted to welcome our first guest, and she is Hind Abdullah, researcher at Khalifa University in the United Arab Emirates. Hello, Hind, you're very welcome today.
Hello, thank you for having me today. I'm really excited to participate and joining from United Arab Emirates.
Thank you, Hind. Thanks for joining us. We really appreciate it. So you've done a lot of research. You've read a lot of papers on operations and maintenance and solar, and you've quantified them all and done a wide analysis of a lot of industry research and papers. And basically, in your research, you've written that there tends to be a kind of an install and forget mentality among many in the solar industry when it comes to operation maintenance. What did you mean by that?
Okay, so when I talked about the install and forget mentality, I was actually referring to a pattern that we saw repeatedly in the literature and also in the industry. So the focus was on rapidly deploying plants. And once these plants started producing energy, maintenance was perceived as something to minimize rather than like a proactive or a strategic activity. And because PV systems have relatively simple design, so there was a misconception that they would require minimal maintenance. But and of course, this is really not a negligence, but I would say it's overconfidence in component reliability and also very competitive pricing structures that made the operation and maintenance budget limited. But I think that this is currently changing. So as the PV capacity is expanding, I believe that now there has been more investment in condition monitoring systems, UAV-based inspections, thermography, AI-based diagnostic, and operators are now realizing the value of or the cost of under-maintaining PV assets like higher degradation, performance losses, or missed revenue. So I would say that this is now changing. So the industry is moving from the install and forget mentality to install and continuously maintain.
That's good to hear, Hind. I suppose that things are changing, and there was a bit of a culture of complacency, as you were saying. And just to say to you all watching at home or in the office or wherever you are, that you can send in your questions to Hind and to all of the other guests today using our chat function on Big Marker, which is our webinar platform. So you can just feed them in as you have them, feed them in live, because it's a live event. We'll keep chatting to Hind anyway. So yes, Hind, I want to kind of move to, so you noted a very interesting pattern as well in the paper, that operations and maintenance in wind and the hydro industry is much more advanced than solar. Is there something that the solar community can learn from these other industries, do you think?
Okay, so first of all, for the wind industry had to mature its operation and maintenance earlier because compared to previous systems, wind turbines are more mechanically complex and they're often deployed in remote or high-risk environments. So unplanned failures are extremely expensive, and that's why the wind industry had to invest earlier in SCADA-based analytics or reliability modeling and structured maintenance approaches. And I would say that this is also evidence in the large number of publications from the wind operation and maintenance compared to the PV systems operation and maintenance. And I would say that the solar industry can learn several lessons from the wind industry. For example, the most important thing is collaboration. I can see a lot of collaboration between the industry and researchers in the wind industry, and open partnerships or data partnership as well. The use of digital twins, reliability modeling, and continuous feedback loops. So what I really see in the wind industry or the wind publications, that the operation and maintenance data from the wind systems are continuously being integrated back into the system themselves to validate, to plan, to design. So I think that if this has been followed in the solar industry itself, the learning curve will increase dramatically.
Okay, yeah, good. So let's go into so there's different types of maintenance, as we know. So there's predictive maintenance, preventive maintenance, adaptive maintenance, prescriptive maintenance, and you've written about all of these, of course, in your paper. What are the most I suppose important methods to master? And I mean, does it depend on what a plant's individual needs are? I mean, I presume it also depends on where the plant is located and what you're looking for out of this plant. I mean, everybody wants to make money.
Yeah. Okay, so I would say actually the selection of a right strategy, it depends on the plant itself. For example, small rooftop installations with limited monitoring systems, they can rely on simple preventive methods. However, large utility scale systems with rich data can support more advanced predictive and prescriptive maintenance approaches. But I personally think that the different maintenance strategies, they overlap. So they don't really exist in isolation. And the modern PV operation and maintenance is now moving towards an integrated, data-driven maintenance ecosystem where everything like collaborates together.
Okay, and I suppose you recommend that people sort of go with the individual needs of their plant, like you say. Smaller plants maybe need a little bit less, and then so it really depends on balancing the investment and the gain.
Yeah,
I suppose if you're investing in technology, would that be fair to say? Yeah. Are you seeing any particular trends emerging, like technology trends, for maybe like digital twins for adaptive maintenance, for example, and or prescriptive maintenance? And are you seeing these trends emerging, and how might they impact the industry in the future as we go forward?
So after we published our review paper, we saw really an increased attention towards prescriptive maintenance, or what we call maintenance 5.0. So the PV industry, or till my research paper, we stopped at predictive maintenance, which is anticipating failures in advance. However, a new paradigm, which is prescriptive maintenance, it builds on predictive maintenance by recommending the optimal actions at the right time. So it can assist operators to know what to do, when to do it, and which resources to deploy. So I think this will really help operators to balance all resources, like efficiently prioritizing repairs, smart scheduling for the repairs, and also allocate the resources where they yield the highest impact. So I think this is the current trend, and it's a hot topic in the current literature as well.
Great. Yeah, good. So I suppose for like specific technologies, are you seeing any specific moves, any specific interest in them?
Yeah, so two emerging technologies are actually receiving attention: digital twins and reinforcement learning. So
Okay,
just to elaborate a bit, so digital twins, it assists operators to create a virtual replica of the plants, and it can continuously be updated with real data. And reinforcement learning is actually the AI algorithm that can be used to test different adaptive decisions. And both of them, they can assist operators in practicing adaptive decisions in a risk-free environment. So I would say these are the two emerging technologies.
Okay, and do you think that both of these technologies, digital twins and reinforcement learning and machine learning algorithms, do you think that they'll lead to more long-term secure strategies? Will they lead to? Are you already seeing that they're improving things on plants? Are you already seeing the benefits, or are these being tested yet?
Well, in the industry, I don't think that it has been tested fully, but they do start as decision support systems. So we are still keeping human in the loop. So operators, they do have the flexibility to refine, adjust, or validate the recommendations provided by these systems. So that's why I always think that the industry should be open to experimentation from us researchers, the algorithms, the technologies that we provide. And if both parties work together, I believe that we'll be seeing more of these technologies adopted in the industry.
Okay, great. And what are you working on at the moment, Hind?
So, yeah.
Sorry, go ahead.
Okay, so yeah, actually, we started to work with reinforcement learning for cleaning optimization. So we worked with predictive maintenance, and now, as I mentioned, as prescriptive maintenance is the newer paradigm. So we want to use reinforcement learning for adaptive cleaning decisions, because soiling is one of the main issues that we're facing here in the Middle East.
Okay. Yes. Yeah. That's very true. The Middle East has different needs on O&M for compared to Europe, which is quite interesting. Hind, I mean, this has been a very interesting insight into the current and emerging research trends in PV operations and maintenance. And thank you very much for starting us off today and for helping us to explore them. And I'm gonna let you go. And I just want to wish you a very happy National Day, because today, December 2nd, is the UAE's national holiday. So I believe you're going off to celebrate that right now.
Yeah. Thank you so much. Thank you for having me.
Thank you very much. Thanks for joining us. That was Hind Abdullah, researcher at Khalifa University in the UAE. So thank you very much to Hind for joining us there. So Hind has contextualized some of the current and emerging applications for technology in operations and maintenance, and she's given us an indication of some of the problems and pain points those in the industry are facing. Now it's time to hear from some of the people addressing these needs, and I'm very grateful to our panel of industry guests who are joining us to share their perspectives. Just one moment. Okay, so we have, in no particular order, we have Werner Copier, CTO at 3EE, Darrell Liu, CEO at LCOE.ai, Paul Fontaine, co-founder and CEO at SkyVisor, and Andreas Stordal, Vice President of Production Optimization at Scatec ASA. Thank you all for joining us. So Andreas, we'll go to you first if you're there. I
am.
just want to ask you a little bit. Hello, how are you? You're joining us from Oslo, I believe.
That's absolutely correct. I'm all good, thanks. Thanks a lot for having me.
Good, good. I wanted to start off with Scatec, their IPP and EPC, with operations all over the world. What are the main challenges and I suppose pain points in the industry at the moment, Andreas?
I think sort of the fundamentals of PV and renewable O&M and the sort of challenges we have there are quite similar to what they have been for quite a long time. Ultimately, right, sort of PV renewable O&M comes down to sort of three key aspects or sort of pillars, as we often refer to them, which is we need to keep our people and plants safe and the nature free from harm. We need to operate the asset in a way where we maximize the value generation, the revenue generation. Historically, that has often meant maximizing uptime, maximizing your performance ratio, or power curves of the wind turbines. There are some changes on that side, but I'll get back to that in a second. And lastly, of course, we need to do this in a way where we have a cost-efficient operation and do it at a cost level that is competitive. And as Hind has already mentioned, there's obviously been a substantial focus on this, particularly recent years. I'm glad to say that I sort of agree with Hind's evaluation that it seems fortunately sort of we bottomed out a bit in what was, I guess, effectively sort of a race to the bottom there for some time, and that we see sort of investors, partners, lenders also sort of gradually waking up, so to speak, to the value of good holistic quality O&M services. So while those sort of three pillars are quite the same as they have been, there's quite a lot of movement within those, so to speak, and where technology and new technologies are quite essential for how we're going about that as an O&M service provider. Firstly, there is a scalability challenge. Again, that isn't new per se, but it's one where I guess we could say, fortunately, from the PV industry side, it's just increasing in extent, right? Because we're deploying more and more plants. Many of the plants are just getting bigger, which means that we need to have digital tools and a digital sort of foundation which allows us to operate these plants in an effective way, where we can detect easily any anomalies that we would see, and leverage basically the economies of scale that you can get from those type of increasing portfolios and increasing plant sizes if you're doing it correctly. Lastly, however, to add to that challenge, we also need to scale now, let's say, an additional domain, which is sort of multi-tech side of things, and where, of course, from Scatec's side, for instance, we've gone in quite a few years from being predominantly an operator of PV assets to now operating also hybrid assets, BESS assets, etc., which means that also there's challenges coming that side, which we need to adapt to. Then, as I heard, was a focus area of the webinar in this series from yesterday. There's sort of a transition where we're moving, you could say, from the focus on kilowatt hours to more energy services, right? And where historically we've had a quite strong focus from our partners on how we can maximize sort of uptime, maximum performance ratio. By all means, that focus is still there. However, we also now see an increased focus on sort of the predictability of this and the control of the energy, and where our partners are sort of challenging us on how can we also improve the forecasting side of the production, how can improve our sort of maintenance planning in a way where that also contributes to improving the revenue stream of the assets that we're operating. Lastly, as Hind has already also touched on, there is a big push within the space of automation and robotization, not at least. I mean, the use of drone for instance, thermography purposes has already been quite commonplace for a few years in the PV industry. However, we see now that the amount of use cases are increasing. Also, for instance, with the introduction of docked drone solution, where all of a sudden also security applications, ad hoc visual inspections, etc., are becoming really good technology enablers for providing efficient O&M services. And there's, of course, also within the space of robotization, module cleaning by use of robots, there's vegetation control, also ultimately even equipment inspections, etc., where there is technology emerging for doing that by use of robots. And then, well, we're still fortunate, I think, that at any given time in the PV industry in the last years, a very big part of our total operational portfolio has been built through the last 1 or 2 or 3 years, simply by virtue of the significant growth that we've seen in that industry. Now, that being said, I think we and a lot of other operators as well are seeing an increasing part of our plants sort of becoming 10 plus years in operation. And so we are working quite a bit from our side in making sure that these plants are sort of entering midlife gracefully, so to speak. That means that we sort of need to keep close eye on equipment health, condition monitoring, module health, and sort of degradation evolutions, etc., are quite key sort of focus areas of the module health programs that we have implemented at the plants that we operate. And I think also, as Hind touched on, while that, of course, is creating, let's say, some challenges we need to address, it also creates, we see some opportunities because we have plants then which are out for a large part of their respective warranty periods, and which means that also there is a scope for adapting your maintenance program by using sort of reliability-centered maintenance methods, etc., to also, again, there address sort of the cost pillar side of things, which still continues, of course, to have very much focus, although in perhaps a more healthy way, I think, now than what was the case a few years back. There's many other things I think that are quite exciting moving in the technology space as well. But I will take a pause there as I know that there's other panelists as well that are very much working with interesting and good solutions to some of these challenges and trends that I've been mentioning.
Thank you very much, Andreas, for that. Yes, and you mentioned drones and digital twins and AI and automation, which are all great. And we have other excellent panelists as well to talk about those. So I will go to, because you mentioned drones, I will go to Paul Fontaine from SkyVisor. Thank you for joining us, Paul. I believe you're joining us from Paris. Is that right?
Yeah, that's correct. That's correct. Thank you so much for having me. Thank you.
Yeah, good to see you. So Andreas mentioned a little bit about the new opportunities for drones, and I know that SkyVisor does thermal tomography monitoring, and you also do monitoring for inspections for solar park construction. But I want to talk to you a little bit about the I suppose how these tools are being used for on-site maintenance, inspections, routine maintenance. How are these being used right now? These drone solutions.
Yeah, well, drones have always been a fantastic tool, I would say. Unfortunately, not always making the headlines for the good reasons, but in the back office, it's definitely a very powerful solution that should be in every technician's or asset technician's toolbox, I would say. And as Andres mentioned already, it's been quite widely deployed. I would say there's a couple of reasons for that. Over the industry, it's always deployed in the wind industry. That has been mentioned as well a bit about by Int, I would say. And there's a couple of usages. The first one, most obvious one, is definitely the thermal inspections. That's been around for a couple of years. Now there is, of course, more inspections that can be carried out by drones. We've been talking about electroluminescence. That is a very specific type of inspection that we do to sample a couple of modules. And as Andres mentioned, now we are seeing more and more automation in this field using dock solutions. So basically, drone garages, I would say, that can cover very wide spaces of PV plants, but can also bring new applications like security applications, indeed, and construction monitoring, where we need a very high volume of inspection. Yes.
And this is, I mean, it's important, I suppose, for the construction monitoring to start from the beginning with these monitoring solutions. It start as you mean to go on, I suppose. And drone legislation is also becoming simpler. You mentioned some of the headlines. We won't go into those. Drones flying over airports, but for solar, they can be good, which is important. But I suppose because like there's also you can also automate your workflow once the raw data from the drone is fed into your app or whatever the case may be. So it's streamlining people's workflows, making it easier to have a sort of an eye over all of your different plants and scale, would you say?
Yeah, definitely. I mean, and drone has been evolving very fast. It's been following the trend of smartphones. So there's, I would say, two main factors that are bringing drones now in everyday all technicians' toolboxes. I would say the first one is legal aspect, as you've been mentioning. Now there is a unified European framework that enables all the different European countries to be following on the same framework, and that eases a lot the deployment of such solutions. So now the training lasts only about 2 hours. It's a free online test. And the second factor is the drone prices as well. That has been drastically dropping over the last years. So now a drone is going to be about 4,000 to 5,000 euros. So this is mostly for the legal aspect, but as you've been mentioning, indeed, there is the more operational view, and to make sure that everyone can do their own inspections, it requires indeed a lot of automation on site. So they will be leveraging on computer vision, on AI algorithm as well, to make sure that technicians can actually inspect whenever they need. And that's a very interesting part, I would say, of this kind of technology, that it can really be in-housed to leverage the full power and full potential of drones, because it's a fantastic tool that can scan extremely fast a PV plant, but this can be done so only if it's deployed at the right time. And deploying at the right time means having the drones always ready with you and not having to rely on to a third party and a subcontractor that, of course, needs and requires some authorization eventually, or even some travelers to come on site. So it really brings a lot of new applications, I would say, onto the maintenance spectra, like post-incident inspections, post-ailing inspections, for example, that before was very hard to conduct because all the different pilots and drones were busy flying. So right now, as you have it in your toolbox, as you could have a driller, for example, you can definitely use it whenever you need it the most. Yes.
Okay, thank you, Paul. Yeah, let's go to Werner next from 3E. Hello, Werner. How are you?
I'm great. Thank you.
Good. Thank you for joining us. I want to ask you because you have authored quite an interesting paper that I read before this session about digital twins, and Hind also mentioned digital twins earlier, and indeed they've already been mentioned a couple of times. Yes, I mean, just to get an insight from you, how are these solutions being used in the industry in Europe at the moment? How is this evolving?
Yeah. So if you look at digital twin technology, and I think Hint gave a very good, like of a definition of what it consists of, it means in practice that you structure your data, and that means data that you collect, but also the data that you produce with your assets over the lifetime of your assets along in one structured information model. And this is one aspect of the digital twin. The other one is that it provides you a very good estimation of your expected behavior of your asset at all times. So these are the two phases of what we consider a good digital twin solution. And if we look into the practice of a PV asset lifetime, you start in your feasibility phase with performing your business modeling, creating your first business models, your first designs of your asset. You go into an engineering phase where you end up with a detailed design. You go into as-built information, commissioning information, trading information, because your asset will need to connect to the grid. You start to collect all of your monitoring data, and you want to make sure that all of these data sources, they become available in your workflows in a digital manner, and that you're not relying on tons of imports and exports from different software solutions in order to manipulate this data and to make this data available in your workflows and business processes. So this means that your financial modeling data, your engineering software, your drone inspection data, your field service management data, your monitoring platform, they all need to speak the same language. And that's a digital twin solution enables you to combine these across your workflows. So I do believe that digital twin solution as such it's not only about this aspect of interoperability, making sure that you talk the same language. It's of course very much about what you do with it and how that combination of data sources allows you to unlock analytics and to do better decision making, even when talking about very complex data manipulations. So improving your decision processes, both in the as an O&M, but as an IPP, or as a financial asset manager who needs to have a very good view on where your asset stands after 10 years versus your business plan, and whether it makes sense to start restructuring or not. So all of these aspects come into play, and going into that type of a prioritization of actions, and where you can really decide on yield improvements based on a return on investment, and taking preventive maintenance actions there is really key in the value that a digital twin solution can unlock.
Okay, yeah, thank you, Werner. Sorry, did you have anything to add there? Sorry,
Yeah, and if we look to where we stand at the moment in our industry, I think it's good to reflect where we see, because we see best practices popping up and people starting to deploy digital twin solutions. Most of the O&M providers and best practices, we see that they're still getting stuck at normalizing their tax structure and their monitoring data, which is of course important and fine, but this is the first step. You need to leverage that digital twin technology on top of that in order to create that interoperability and make your data work together.
Okay, thank you. And I know there's different types of digital twins as well. There's different models, but just before we get a little bit deeper into digital twins, I just want to go to Daryl first, because Daryl Liu from LCOE.ai, you're based in Georgia, is that right, in the US? So it's very early morning for you.
Yes, it's very early.
Good morning. Good morning.
But happy to be here.
Thank you for joining us. So I mean, like, you know, we all, like, we've heard here that the solar industry is very fast growing, competitive. In Germany, for example, it's been building out since the 2000s. But do you think that that the industry is now sort of playing catch up and forced to deal with the operational efficiencies? And LCOE helps. You're an expert in helping solar O&M professionals and EPCs make sense of their data with using technology automation tools. So do you find that they're struggling with like these and we've heard a little bit about kind of siloed data, poor maintenance strategies, difficulty scaling. So is it kind of has the industry come to a reckoning at this point? Is it at a turning point maybe where it needs to adopt more technology?
Yeah, I think that's where the industry is playing a little bit of catch up. I mean, I've worked in prior industries like large scale manufacturing and energy, and those industries are in a lot of ways still 10, 15 years ahead of where we are in PV and especially in BESS. What I see also is, much to what Werner said, is that many organizations are still stuck really with a lot of muddied, siloed data. There's just a lot of noise, right? So a lot of folks are still trying to normalize the data. They're still trying to figure out what is their digital plan. And quite frankly, everyone talks about AI. So should we be doing AI? And so everyone just from the top down is saying, use AI. And so I'm hearing a lot of folks just saying, hey, so we have a strategic initiative right now for AI. It's like, great. What does that mean? They're like, we're still figuring that out, right? But they're just being told. And so there's just a lot of noise right now where, especially here in the US, where you've also had tax credits. Of course, here in the US, that's now going away. But there's been this huge momentum and push, just throw panels on roofs on the ground, and not a lot of real care to how is the asset really going to perform long term, right? Going back to even what some of the things Andreas talked about, right? There wasn't as much of the financial stewardship. It was more about, hey, how can we develop really quickly and let's move on to the next project, let's reap the tax credits, and the like. And I know that Europe is far more, it's much more evolved in many of these kind of circumstances, but we're still seeing a lot of these organizations with still siloed data messes. And a lot of those siloed data is also because most of these softwares have also in some cases fell backwards into success because they were born out of really mechanical engineers and electrical engineers who really needed some software to serve their purpose. And it's just happened that, they talked to a few other folks that wanted to do it, and then they started launching software companies or whatever it is. And so they end up having all these different types of siloed technologies that are very much, in some cases, like Web 2.0, right? Mm-hmm. They're not really thinking about, whether it's API-driven architectures, interoperability. Struggling this morning. It's 5:38 a.m. So we're just seeing a lot of that. And again, a lot of the teams, a lot of organizations are just, they're still stuck in the muddy mess of their data and how to best leverage it, right? It's not just about, hey, great, I created this data lake, right? I'm using Snowflake, I'm using AWS, I'm using this. So what now? Everyone's trying to figure this out, but they're trying to effectively build the plane while they're already in the air. It's best to kind of really sit down and understand what are you really trying to achieve. And contrary to most folks, most organizations are not snowflakes. You're not really that special. There's very much things that you can learn from one another, and you don't have to always build from the ground up.
Okay, yeah. I suppose that's some good advice. Just not to throw everything at not to just invest in a technology just because it's making headlines, but to actually reap the value from it is important. And I just for the PV industry specifically, how are you seeing? So you deal with O&M personnel, O&M staff workers. How are you seeing them on the ground get the value from, the data from the sensors, inverters, the SCADA systems, whatever tools they have? How are you seeing them get results to ultimately, I suppose, lower their LCOE and maximize their revenues, boost the bottom line, I suppose, as it was?
Yeah, I see this in a couple different ways. I mean, like, so most of our customers are asset owners, your IPPs and corporates. And then you also do have like those folks that are serving the O&M. O&Ms, and these are also in some ways they're challenged in different ways. O&M providers, they typically have a much more of a smorgasbord of different data and systems because they're working with the client. So really it's about like how to also understand what's actually being presented to them and all the different noise that's happening. We find across the industry is that there's just a lot of noise that's being kicked off by all these different kind of monitoring systems. And so most folks end up being very much desensitized to what's really important, right? But also then you need to couple that with some financial prioritization or even contractual obligations that really helps them understand that when you really think about it, not every plant should be treated the same, right? Mm-hmm. There are different, not only contractual obligations, but there also could be a strategic account from an O&M perspective. Oh, I didn't even mean to do that.
It's okay, no worries. It's all live. It's fine. Don't worry about it.
I did not mean to just give myself a thumbs up. So anyways, whether that's very much time savings, so they don't have to muck around trying to figure out of the 100 sites, what are the 10 sites that really matter? And then how do you drive those value back to the customer, which then at the end of the day, right, not only does that impact the O&M from new logos, but also renewals and recurring revenues from that perspective, right? But also on the IPP or asset owner side, they're ensuring that they are capturing or having the most reliable system as possible, and then able to obviously generate the highest returns that they can based on their models, right? So when they have portfolios, it's about how do you turn from more of a reactive and more into a predictive and more, even some cases, prescriptive.
Okay. Yeah. Thank you. Yeah, it's interesting to hear how this will evolve, and I suppose as the industry learns over time and becomes more mature, it will be certainly interesting. Werner, I might go back to you just about the digital twin. So just really quickly, I mean, can you explain the difference between physics-based digital twins and data-based digital twins, if it's not too complex to do in 1 or 2 minutes?
No, I should be able. Well,
okay, no worries.
think of a data-driven digital twin as training a model based on your assets data, your monitoring data. So you will use AI technology, machine learning technology to create a model of your expected behavior of your asset based on your past data. If you look at the physics-based digital twin, then you should rather think of your engineering software. You know that in PV, software tools like PV-Syst are kind of industry standard. These type of engineering softwares, they're built out of physical formulas that define the expected behavior in the design phase under long-term weather conditions. What you do is, in fact, when you apply a physics-based digital twin, you will use the same physical formulas, but under the actual operating weather conditions or curtailment signals of your assets to create an expected behavior that is modeled in the same way as you did it in the design, as you did it in the design phase. This gives you as such a big advantage that if you consider a reference period from a statistical model, your PV asset is never behaving perfectly. So you will always have noise, imperfections, failures, underperformances that will be incorporated in your statistical data model that you would deliver. And moreover, you cannot apply it, for instance, during the commissioning phase of your asset because you don't have sufficient data. If you compare that to a physics-based digital twin, that is one where you use the same model as the one that you have been using in the business model. You use it as an absolute reference. So you don't look at historical data in order to train it, which means that you can really bridge it versus your business plan, and you can use it immediately. Moreover, we see what we do when we build out our solar analytics in order to do failure root cause detection and classification. We use a combination of this physics-based digital twin with your monitoring data, and then you're looking at failures not by looking at the noisy PV signals themselves, but by looking at the difference between your expected and your actual behavior. And that allows you to bring much more robust and much more reliable analytics in place in order to do yield improvement and create better business plans and long-term cash forecast for your assets.
Okay, thank you, Ernie. Yeah, it's so it can these I suppose approaches can be tailored according to plants, and so yeah, that's good to hear. And digital twins is certainly a very interesting technology. It's still evolving, as Hind said earlier,
Sure.
and I'm sure you would agree. But I'll go to Paul then, just because Daryl, Andreas, and indeed Werner were talking about a little bit about best practices as well there, and I'm curious to know sort of what for the drone side of it, because drones are quite complex. What kind of training and onboarding and support frameworks are most effective, do you find, in equipping field teams field teams O&M staff to safely operate them and to capture the correct data, because it's specific inspection data. It's quite technical, and they have to think about photo quality, camera quality. They have a lot of things to think about. You can explain more than I can, I'm sure.
Definitely, and I could not agree more with what Daryl has been saying as well. There's a lot of noise everywhere in terms of the data quality, which is a key piece. If you have poor data in, you definitely get poor insights as well. So it's a key part, and in order to reduce this noise, but we strongly believe in as SkyVisor is to always keep the asset owners and technicians in the loop, because they are the one knowing their assets the most. And that's why for us, it really makes sense that those are the ones actually doing the maintenance, doing the inspections, because before maintaining, you need to understand what is the current status of your site and health status of your site. So that's why we're trying to equip them with the best available technology. And this is extremely simple to deploy, as we just mentioned before. Couple of hours of training. Drone tests are extremely simple. Drones are fully automated thanks to software like ours as well. And then this data can be fed into a more, I would say, general digital twin, like the ones developed by 3E. But still, I also agree with Werner in a way that next challenge is going to be interoperability, to make sure that all the different systems could talk to each other, starting with the designs. It's always extremely complex to get a design that could be exported to different systems from PVCs, but also from PVKs or any other software, and after get the most out of those designs to help asset owners take the good decision. Yes.
Okay, thank you, Paul. Yeah, it's also and then I might go back to Andreas just really quickly to ask, now that you've heard all of these these use cases, and I'm sure you know them because you deal with a lot of plants at Scatec, but and I'm not going to ask you what exactly you use, whether you use drones or or what combination, but I do want to know, is there anything that the industry overall can do to make your job easier, to make operations and maintenance at solar and indeed like hybrid solar storage plants easier, I suppose?
Yeah, thank you. I think also would like to say well done, and thank you to Werner for sort of breaking down the digital twin in such clear and not at least non-hyperbolic terms. I suspect sort of myself and Daryl might have found ourselves on some of the same seminars and webinars where this is sort of presented as some type of, I think was it data lake, AI-based driven witchcraft of sorts, right? Which isn't really the case. It's ultimately sort of down to breaking this down into sort of a clear data model, which enables you to detect anomalies, and whether that is sort of a database one or a physics-based one or a hybrid one for that matter, that is definitely something that is very relevant, but also where I think sometimes we're struggling a bit as an industry to sort of match the walk and the talk, so to speak, and to take it down to a level where we're discussing this in a bit clearer terms and what we want to achieve. In terms of what the industry could do, I mean, I think several of the other in the panel have also touched on that. I mean, we are an industry that is again coming from a very high focus on rapid build out, which in many ways is good, but that also means that we have, at least historically, been lagging a bit behind on even such a basic thing as sort of finding a fairly common terminology and nomenclature around how we talk about equipment, right? So that means that sort of when we speak to different providers, inverters, trackers, many of them have very different ways of talking about sort of same data points, etc., which in turns make that very critical part that we have discussed about standardizing your input and having a good basis and a good information model more complicated. I think it's also very important, as Daryl mentioned, to have something here which makes sense for those working in the part of the O&M space which is in the field, right, and on the plants, which after all is by far the most important, right? Seeing that those are the ones who can actually, in most cases, make a difference here in physical terms. And in fact, when we selected sort of a global maintenance management system for rollout around 5 years ago, one of the first criteria we put on the list is that this has to be a system that makes sense for those who are going to use it in the field, because we know both from our industry and from the others as well, if it doesn't, it's not going to be used, and the data quality is going to be horrendous, and people will start taking out sort of spare parts from stock without registering, etc. The second we've done there, I can also mention very briefly, is that we introduced around about the same time data quality KPIs, which has sort of worked quite well, at least in SKATEC, for governing discussions about what we need from data quality, both in the maintenance management systems, but also in our sort of monitoring and analysis systems.
Okay, great, thank you. I'm just going to stop you there because we have on our next panel, we're going to talk a little bit about data quality and KPIs as well. So don't want to spoil too much for now. But I mean, I'm afraid we're going to have to leave it there for this discussion for today. But I mean, hopefully I'll be talking to you again at some stage soon. And I really appreciate you all four of you, Daryl, Werner, Paul, and Andreas. It was a pleasure to have this discussion with you. It's gone far too fast. And thank you very much for answering the questions and for sharing your insights with us. And thank you very much. Appreciate it.